right, ladies and gentlemen, let's take a look. This isn't you. You go, well, what does that look like? So if I go back to my website now, graphing tangent and cotangent, I'm going to click on that. Okay. Notice what you guys see here. This is about graphing tangent. We're going to start with graphing tangent, okay? I'm going to write down some facts, the facts that you guys see on your screen. We're going to write that down as well. So, y is a tangent kx. Again, the k value is positive. And now notice this. This is what's happening here. Your period is going to be what? Pi over k. The interval of one cycle, ladies and gentlemen, is negative pi over 2k and then pi over 2k. So I'm writing this stuff down. It's in that note here. So you're going to need to as well go through this. And I want to mention to you guys a couple of things here. K, what's this? Period. You also have that interval of one cycle, and your k values are over where? Here and here. See if I can get that in there. Okay, here's your k values, right? Now, I want to say something here that you want to really be aware. Even though you have an a value here, and I'm going to get my red out because this is important. There is no amplitude for tangent. So you got no amplitude for the tangent curve as well. And so what that really means, to kind of describe this to you guys, is I'm going to put this as a note. Just the tangent curve, y is tangent of x. Just this. K value is 1. Is that true? Your period is pi, and the interval of one cycle is minus pi over 2 and plus pi over 2. Okay, so I just want to kind of give you guys this note using our definitions. Now, remember, what's the definition of tangent, by the way? Because there's a little bit of details here. I mean, what's the definition? The period, sorry, what's the period again? Do you guys remember what the period definition is? What was the definition? This is the length of one cycle. The interval of one cycle tells you the what? Where that starts and where it what? Ends. Okay, you guys okay with that? Now, I'm also going to say a couple of things here. If you guys notice, these are open intervals. And you can say, what do you mean open intervals? I'm talking about right in here. And what's that? That's right. Well, be careful. These are brackets. This is interval notation, by the way. And you study interval notation in intermediate algebra. So here's the deal now, right? I want you guys to note something that's important here. I'm going to kind of graph this, and I'm going to talk about that detail. I'm going to sketch. Your tangent curve looks and behaves in this sort of way. So you start at negative pi over 2, and you end at what? Let me do this here. I'm going to draw these special red lines. Happens at negative what? Pi over 2. And then these other lines over here at positive pi over 2. Okay, so we're going to put these values here to let you guys know. These are very special. And I put these vertical lines here. Okay? And I'm also going to sketch the curve. I'm going to put a point at the origin. And when we start to sketch the curve here, there it is. Okay, here it is. This is pi. This is pi, and this is the interval of one cycle. Okay, so I want to kind of sketch this for you guys. I want to show you even in Desmos here. Okay, so in Desmos, let's get out the Desmos. Y see y equals. Where'd it go? Hey, Desmos, bring back the keyboard. It's weird. Okay, there we go. Maybe I just scrolled out. Okay. Y equals tangent of what? X. And if you just look at this, you go, oh my God, what is that? If we scroll in, if I can. Come on, let me scroll in. I may have to restart this. Let's go to Desmos. Y equals what? Tangent, okay? And I guess it's in red. I'm going to change the color like I told you guys. Okay, you guys see what I'm saying here? This is tangent in general. This is in general your tangent curve. This is multiple cycles. This is really infinitely many cycles. We don't have to sketch infinitely many. We have to only sketch what? One cycle. Is that right? What is that?
So what can you do like application-wise with tangents?
Tangent function has applications just like sines and cosines. And in general, these functions are used in science. So you're going to have to first learn how to, what they look like. And then later on, we have applications for these curves. So you first have to learn how to graph them. So 2 pi, oops, sorry. Remember that interval of one cycle is not the same. It's negative pi over 2, positive pi over 2. So negative pi over 2 divided by, okay, yep, I think this is the format. Less than x, and then less than pi over 2. Okay, so I'm going to give you more details here. Okay, you guys see this picture? This is one cycle. This is exactly what we're talking about here. This is a graph of tangent here. And generally speaking, all of your curves that you study, and you don't really study like every curve that exists, as you move forward, there's a lot of different curves. You study some curves in algebra, conic sections even. They're called relations, and you take other math classes. There's a lot of graphing and a lot of curves. And you might say, generally speaking, why do these curves exist? Because they represent phenomena around you. And then you work with other processes that involve those graphs in the future phenomena. So there's a lot more graphs out there that exist than what you know so far. And you're kind of just starting that kind of, I should say, that voyage on it. You know, so this is the tangent curve, and this is only one cycle of it. So, I mean, I want to bring that picture in, and maybe it's good to bring in everything. Ah, I don't think I have it all. What happened? Ah, we're going to have to get rid of that. Okay, delete this here. So here we go. That's weird. Anyway, I'll just take this picture here of the graph. Thought I imported it. Oh, there we go. So show you guys here this Desmos picture. Okay, and that's my sketch that I showed you guys here. Is that true? You guys say, oh, there's your sketch. Never guessed my parents are artists. And, you know, this is the period. You say, what do you mean by period? This is the length of one cycle here. And I'm going to go through all the details because you need the details. You see this dotted line I put? And this dotted line here. Any of you guys taking other math classes by any chance? What are these? X is negative pi over 2, and x is what? Positive pi over 2. Is that right? Do you guys know what these are called, by the way? These lines that are not there, but your curve never crosses these lines. What are these called? Anybody taking other math classes? You ever take an intermediate algebra course in your life? Some of you guys might be taking a pre-calculus course even. Anybody taking those? These are some very special lines that we got to talk about. Yes, these are called what? Good job. These are vertical what? Asymptotes. These are vertical what? Asymptotes. Vertical what? Asymptotes. And you say, what is a vertical asymptote? It's a vertical line that your curve never crosses. It gets close to it, but it never what? Crosses, okay? So we're going to identify what's called vertical asymptotes. The vertical asymptotes always happen where you start and where you end. In other words, this tells me where my vertical asymptotes are. And this will be for tangent and also for cotangent, so you guys know. But we're going through the detail. You do have an x-intercept and really a y-intercept too. You guys see the special location? Your curve, what's the location as a point? That 0, 0. So this means this is an x-intercept, and it's also, by the way, a y-intercept. It goes through both the x and y axis. So we're starting to talk about this tangent curve, ladies and gentlemen. All right, so if you said, what do I have to find? You're finding these details. Okay? Now, remember back to the period, you might want to put this together just so you guys know. You might say, what do you mean this is the length of one cycle? Yeah. Your period is always the length of one cycle. So remember this here so you guys know. Just always remember this part. Trying to get the length of one cycle. All right? It's a period. Okay, length of one cycle. Here's the period. If I said to you, how do you figure out the length between two numbers A and B? How do you get the length of those two numbers? If I want to know that distance, the total distance, how do I find that distance? Just kind of give you guys some S, meaning this is discussion. But it's meaningful discussion. It's behind a lot of what we're working with. So how do you guys find the length? If I said to you, can you guys give me what that length is? What's the length between any two numbers? Not midway. This is different. What's length? If I said Al, what's the length? What is it? Al equals what? No. If I said to you, you had to measure, have you ever used a ruler in your life? Okay, how do you measure length of a ruler? You guys know, if I said to you, I'm getting out a ruler here. Where's my ruler? Let's find another color. Let's get a ruler. Go, here's my ruler. Right? You go, okay, I want to measure this. Here's my ruler. How do you measure length? Horizontal length with the ruler. What is it? Nope. Isn't it the difference between B and A? Right? You take the difference between the two numbers. That gives you a length. Is that true? Okay. It's how you measure. It's how you measure distance, whether the distance is horizontal or whether the distance is vertical. If it's vertical, it's up minus top minus bottom. So here's my point to you. You know, on like a ruler, sometimes you might have like an object maybe, and then you bring out that ruler again. If this on the ruler is a 3 dash mark and this is the 7 dash mark, okay? And I might have to fix a little bit of this. Yeah, this will be the 7. You guys okay with that? What's the distance of the object, or how long is that object? You guys know how many units? It's 4 units. Is that true? You say, how do you know? How do you know that's 4 units here? Because it's going to be 7 minus 3. And what's 7 minus 3? So that length is 4 units. Four units. You guys okay with that? Easy peasy lemon squeezy. 4 units. Now, you might say, Mr. Judge, why are you bringing this up? What's the definition of period? Length of one cycle. So if I said to you, what's the length of this cycle? I'm going to get out my purple. What would you do for the length of one cycle here, right? You're going to get what? Pi over 2 minus negative pi over 2. Minus a minus makes that a what? Is a plus. So pi over 2 plus pi over 2 is going to be what? 2 pi over 2. And what does that equal? Pi. Now, didn't we just say the period was the length of what? One cycle? Just to kind of give you that detail. I want you guys to understand that because it's an important little detail people overlook. These are important skill sets you guys have in both logic, math, and science. Okay, how do you even use a ruler? You know, how do you find length? It's going to be the right value minus the left value. And that was applied here in the definition of what? Of the period. The period is always the length of one cycle. And this is only one cycle. You said, Mr. Judge, how many cycles exist? Well, if I took out that, if I just put tangent, generally speaking, okay, I can remove those. Well, I can leave those vertical asymptotes, but now this is infinitely many cycles. And thankfully, we don't have to draw infinitely many, right? You're going through, there's many cycles of tangent here, this tangent curve. So, ladies and gentlemen, we've just started the discussion on how to graph what? Tangent and even cotangent. And I'll show you, cotangent, but it's on that, it's on that worksheet. So I would recommend that you work on your what? Homework. When? When do you guys work on your homework? Is it the night before? There we go. We do have volume. So, ladies and gentlemen, we're going to continue with graphing. Okay. And we left off with finding, we left off looking at the graph of tangent. Okay. And I'm going to remind you guys This is the important information here to graph tangent. Okay? So you got pi, your period is pi over k, as indicated right here. Hopefully that's in your notes, right? And then this is your interval of what? 1 cycle. And I want you guys to note the vertical asymptotes, okay? There is no amplitude, we mentioned that, but I'm going to actually notate here. These lines, vertical asymptotes, are already found right here, where it starts, where it ends, okay? And how we describe vertical asymptotes, I'll say VA, is that we'll say x is negative pi over 2, and x is positive pi over 2. Okay, so they're going to ask for those two things as well. So let's work on some, okay, let's see some other examples here for graphing tangent. So if they give you y equals 2 tangent, let's say, pi x. Or, you know, let's start with 2x, okay? All right, you guys okay with that? Now, what you want to do always is to do the following here. You're going to determine the period, interval of 1 cycle, okay, and your vertical asymptotes, and I'm going to find this here, this thing called an x-intercept, okay? This is the idea behind graphing tangent. And maybe we'll change this here. Well, it doesn't really matter. But, okay, we could leave it as 2. Yeah, let's call it 3. Doesn't really matter here. Okay? So we're going to determine the period. Interval of 1 cycle. Okay. The vertical asymptotes. And then your x-intercept. All right. Does anybody know? Tell me, where do you guys think you start? Where do you guys start with this? What's your definition of period? Period is going to be what? Pi over what? Well, is it pi over 2k or is it pi over k? For a tangent, it's pi over what? K. Remember this? All right. Okay, so let's go back. Isn't this the A value and this the K value? You guys okay with that? And again, what is your K value? 2. So that period is going to be pi over that K value of 2. Okay, now does this simplify here? Do you guys know? Does this simplify? It's your period. What's your interval of 1 cycle? Negative pi over 2k, and then pi over what? 2k. Isn't that what that definition is? So this is a different, ladies and gentlemen, function. This is tangent. And so if k here is the value 2, what is your interval of 1 cycle, ladies and gentlemen? What does that give you? Yup, it's going to give you negative pi over 4, positive pi over what? 4. Okay, you guys okay with that? Okay. So now let's say, well, what does that mean? Your vertical asymptotes will happen at x is negative pi over 4 and x is what? Positive pi over 4. This gives you those vertical asymptotes. This is an open interval. Yes?
I'm a bit confused. So I know the period is pi over k. That could be pi over 2. So interval, I guess, is pi over 2. Yeah, where was that? I'm a bit confused. I thought k was equal to 2. So
Well, if k is 2, what would be that 2 times 2?
4.
So that's why that first part is negative pi over 4. So then, again, over here, 2 times 2 gives you another what? Positive pi over 4. So the interval of one cycle is going to be negative pi over 4 to what? Positive pi over 4.
For tangent was like pi over k and not pi over 2k.
Well, we've moved past the period. We already got the period. We're talking interval of one cycle,
Okay.
right? So the interval of one cycle, you plug in the k value. And what that gives you is where you start and where you end. But it gives you, again, these things called the what? Your vertical asymptotes. So when you start to graph, here's what that is. Okay, now negative pi over 4. What's a vertical asymptote? You're going to draw these vertical lines here. Okay. So negative is to the left, positive is to the right. I'm gonna say something about this here so you guys know. Okay. There's going to be some symmetry here, right? This is what's called a symmetric interval, meaning you have that positive and negative value. They're the same values. And so if I ask you guys a question here, because they're going to want you to find the x-intercepts. How do I locate the x-intercept when you have this symmetric interval? Tangent, like we described earlier here, the tangent curve with that symmetric interval here, okay, puts your x-intercept at 0. Is that right? But if I noted this to you guys and said, hey, what's midway? What's midway between these two lines, these two values here, right? That's going to be 0. And you say, well, how do I know what's midway? Right? Isn't it negative pi over 4 plus pi over 4 divided by 2? Isn't that 0 over 2, which is going to be 0, ladies and gentlemen? So the point I'm making is, when they say, where is your x-intercept now? Because they're going to want you to find that. Your x-intercept happens at x equals 0. The address is 0, 0, just so you guys remember that. But being midway between those two symmetric values, and yeah, it's a vertical line, so we write down x equals negative pi over 4 and x equals positive pi over 4. You get to sketch the curve now. And the curve will look like this, ladies and gentlemen. Okay? So those of you guys that take pre-calculus, I actually write down x cubed. That's what makes me remember this curve. That's kind of similar to the x cubed curve. So if you guys are taking that intermediate algebra or even pre-calculus, this is what this is what I remember in my mind. Now, I also want to say to you guys something here. Remember this a value being 3? Well, there is no amplitude for tangent. This is a tangent curve. So remember that important detail. You're graphing tangent. And with tangent, like cotangent, there is no amplitude. So that value 3 is just a constant in front of the tangent that could make this sharper or wider, meaning it's just a sketch. I'm not going to compare, different values of A there, but it's just a sketch. And so you just draw your tangent, this curve getting close to the x-intercepts. But the point I'm making is there is no amplitude. Okay, so A here is positive 3. Do you guys okay? Are you guys okay with that? So there's no amplitude. But what happens, let's see if you guys remember from Thursday, what happens if this is negative? This is an important detail. That has meaning. There's still no amplitude. But if that value is negative, how do you guys think that affects the curve? How did it affect sine and cosine if that A value was negative? Do you guys remember? What's the effect? The curve now is symmetric about the what? About the x-axis. Meaning your curve for a negative A value will be what? Like this. Okay, it won't be what we just drew. It would be reflected about that x-axis because this is the x-axis. So I want you guys to know that because that's extremely important here. Okay? So I'm going to share with you guys this curve in Desmos, if we still have it. Where's Desmos? So y equals 2 tangent 2x, right? Then we do that one. And then we're going to put the interval of one cycle. And I believe that was going to be negative pi over 4, right? Comma, positive pi over 4. I think we forgot to put the, yes, less than x, less than or equal to pi divided by 4. Well, we can put 3. Okay, and then I know this, you say, boy, that kind of looks a little weird. Well, let's actually adjust the x-axis. You could do that here. So we can make this like between negative 2, positive 2. Does that help? Maybe that helps a little. And I'm going to change this curve. Okay. And then if you said, well, what if you put the negative sign, right? This curve is the positive. This is the tangent curve. What if you put negative in front? What happens if there's a negative now? So you guys see how it switched? So positive and then what? Negative. Positive, negative. I didn't list the vertical asymptotes. I can. Okay, so you can see every detail. And you guys know I like to put these in red and make the lines dotted. So as you guys can see, that was the original graph, Sorry, the original graph was positive. There you go. And so, ladies and gentlemen, that's the story. But remember, if it's negative, we put that negative sign. All right, you guys okay with that? Easy peasy lemon squeezy? All right, so now if I said to you, well, let's try this example. Okay, they give you y equals maybe 1/2 tangent negative pi x. And you go, oh no, what if they did that? Pull out your what? What do you guys remember about this curve? Do you guys remember anything about tangent? Tangent is what? Isn't tangent an odd function? So what does that mean about the negative sign then? Do you guys remember? It comes out. Is that right? And there you go. So this is the first thing you have to do, because that value of k, which is right here, k now is what? Isn't k pi? So your period, because this is tangent, is pi over k, which means it's pi over what? Pi. So ladies and gentlemen, your period is the number what? Is 1. Easy peasy lemon squeezy. You identified the k value, so pi divided by pi is 1. Now, ladies and gentlemen, what's your interval of one cycle? What's the definition? This is the tangent curve. So for your tangent curve, it's negative pi over what? 2k positive pi over what? 2k. That's the definition, because the curve is what? The tangent curve. This isn't sine. This isn't cosine. So you have a different period formula and a different interval of one cycle. What is k again? Pi. Didn't k always have to be positive? Is that true? So k was positive. Okay, k is pi. I plug in my pi for k, and then you might say, well, what does that do? That's negative pi. Maybe you need to see that. 2 pi. Positive pi over what? 2 pi. Cancel the pi's. What's that interval of one cycle going to be? It's negative 1/2 what? Positive 1/2. All right, so ladies and gentlemen, what do you guys do now? What do we do? What's the first thing? What's the first thing you guys do? They're going to ask you for the vertical asymptotes. What are they? X is negative 1/2, and X is what? Positive 1/2. It is always these values right here. Is that right? Okay, you guys good with that? Okay, now where are they? They're over here. Do you guys notice that symmetry again? Do you guys see my point? How it's symmetric? Where is the x-intercept going to be? Right in the middle. Is that right? What's that value? X is 0 is your x-intercept. And then, what else you guys have to remember? Anybody remember? What's the value here for this a value? Your a value is a negative what? Is that an amplitude? No, this is tangent. There is no amplitude. But how do you use that information? That means this goes how? This goes, the graph looks this way. Oops. Okay. I was going to try to move it. There you go, ladies and gentlemen. There it is. What do you guys think? All right. Well, have you guys try one. Let's see what you guys think about this. You guys ready to try one on your own? Okay. Let me see my, I'll share this with you guys, show you what I mean. What you'll have, if I haven't put it already, we're going to go to the website. And remember, I'm going to go down all the way here. Graphing tangent and cotangent. You guys see that? So let's try something like this. How about y equals 5 tangent see if you guys can see this. 5 tangent x over 3. Okay, x over 4. You're going to determine all those things we worked on. What did we work on? What's in your notes? Should I copy that? Let's copy that. Okay. Find all these things, okay? You're going to sketch that curve. I'll give you guys some time. And okay, we'll use the lucky number 8. How's that? All right, ladies and gentlemen, here's the deal. A, and then focus right in here. Okay? This is x over 4. You have to write it as 1/4 x. Does anybody know why? Because the number multiplied to x, what is that? The number is not 4, it's 1/4. That's your k value. Is that right? You guys with me on that? That's k. So you need to know that because your period for tangent is pi over what? K. So k now, you replace k with what number? Not 4, but what? 1/4. That's an extremely important detail. Okay? So this would be 1/4. Now, what's your arithmetic? Pi divided by what? 1/4 is pi times 4/1. We know this as 4 what? Pi. So I'm just going to write it down this way. Period is 4 pi. Good. We got the period. And then now what do we need? The interval of one cycle. And what's that definition? Your interval of one cycle, ladies and gentlemen, that's going to be what? Negative pi over what? 2k positive pi over 2k. K is 1 what? 4th. So now, what's 2 times 1/4? Do you guys know what that is? Right, we're talking arithmetic right here. What's the 2 times 1/4? Good. So this is going to be 1/2. And the other one's going to be what? 1/2. You guys okay with that? Okay. So you might say, Mr. Judge, I don't know what that is. Well, what's this? Isn't that negative pi times what? Well, let me give you very detail. That's negative pi divided by 1/2, which becomes negative pi times 2/1. That's negative 2 what? Pi, okay? And the other one's going to be what? Positive 2 pi. So my interval of one cycle becomes negative 2 pi and then positive what? 2 pi. Here we go, ladies and gentlemen. There it is. So hopefully you guys did this arithmetic, okay? Division, arithmetic. You guys okay with that? All right, now, what does that mean once you get this interval? That means a lot of things, right? I could now say to you guys, vertical asymptote is x is what? Negative 2 pi, and then x is positive 2 pi. Easy breezy? Where's your x-intercept now? Well, maybe you say, I don't know, but okay, let's take a look here. We're going to sketch this, and I think I can do this here if I write on it, yeah. All right, we can write on that. Where's your x-intercepts, ladies and gentlemen? Negative 2 pi, positive 2 pi, right? So go to the left. And go to the what? Right. X is a negative 2 pi, and then x is a positive 2 pi. Okay, the x-intercept, again, where's the address of the x-intercept? Where's your x-intercept, ladies and gentlemen? That happens where x equals what? 0. That's way over where? Here. So sketch your curve now. How does your curve look? Like this, and then how? Like this. Isn't this a positive a value for tangent? Right? A here is positive, not negative. So there you go, ladies and gentlemen. What do you think? Is that easy peasy lemon squeezy? Yes.
I got stuck with multiplying 2 and 1/3. So I'm not sure how I'm supposed to multiply horizontal or do the whole diagonal thing.
Okay, the question is, you got stuck with what?
How to multiply 2 and 1/4.
Well, okay, right in here. Here's the question here, right?
Yeah.
All right. So let's do a little bit of this here. Let's remind people here. So here's the question. How do I do this arithmetic? Okay. You take a whole number times a fraction, right? So I'm going to put it in purple here. If we say a whole number like this, A times what? B over C. There's a whole number times a fraction. Is that true? Now remember, this goes back to the idea really of multiplying fractions. You go, what do you mean? I don't see a fraction for the first whole number. Okay, divide by what? 1. Is that true? All right. What do you do now then?
Diagonal multiplication?
Well, yeah. Well, here's the deal. You have your algorithm for multiplying 2 fractions now. So the first fraction is going to be A over 1. The second one is B over C. So now you might say, well, what does this become? This is A times B over 1 times C, which is AB over what? C. So the specific question now for people is this. 2 times 1/4? You say, what is 2 times 1/4 now? Well, 2 divided by 1, okay? Two fractions, is that right? So how do you multiply these things? Do you guys remember? You multiply horizontally what? Across. Trying to do an arrow. There we go. Two over 4, which gives you now what? 1/2. Now, okay, you guys okay with that? So now you might say, oh, Mr. Judge, boy, I need a little bit of some work here. Well, let me go to my website now, and I think under beginning algebra, all right, 115, worksheets and videos. Algebra lecture 2, multiplying what here? See this multiplying fractions, algebra lecture 2? That was the old Mr. Judge, algebra lecture 2. So under multiplying fractions and simplifying fractions, I'm going to put this in the comment section for folks. You may want to do a little bit of some what? Some review. Simplifying fractions, multiplying fractions, dividing fractions. Okay, but that's the algorithm that we employed here for this question here. 2 times 1/4 gave us what? The 1/2 you guys see here. So, it's kind of the thing where people say, hey, you know, these courses ultimately involve arithmetic, because they do. Okay, and then let's give you guys this graph here. Or let's give you guys a note here. What about the tangent curve? Okay, because also I have to now come out of the algebra mode, beginning algebra, and we're going to go now to 241. Okay. You might say, are we going to graph cotangent 2? Yes. What do you guys see there? A cotangent kx, k is greater than 0. What's the period here for cotangent? Isn't that the same? It's pi over k. But notice the difference now. The interval of one cycle is no longer negative pi over 2k, positive pi over 2k. It's 0 to pi over k. So let me write that down in our notes here, okay? So in our notes, we're also going to graph cotangent. The period, ladies and gentlemen, generally speaking, is pi over k still. But the interval of one cycle now is 0 to that period, which is pi over k. Okay, and I'm going to put another sort of note here to say, well, this means, go back over here to see what that means, 0 and pi over k. What you're going to see also, for example, is that the vertical asymptotes will also be, where x is 0, x is pi over k now. So vertical asymptotes. And then that's going to affect the x-intercept. I'm going to share with you guys again. You say, well, how am I going to get the x-intercept? Well, I'm going to describe it for you guys now right here. The x-intercept, so you guys know, is midway between the vertical asymptotes. We're going to see that. Now, this is generally speaking, okay? Generally speaking. So, to start off, like I did before, I'm going to be consistent here with this. I'm going to write it as a note. I'm going to say to you guys, the standard curve, where this comes from, cotangent, okay? Obviously, k is 1, so that means the period here for cotangent is pi. The interval of one cycle will be start at 0 and at pi. Okay, your vertical asymptotes, x is 0, x is pi. The x-intercept is midway. What's midway between 0 and pi? Do you guys know? It's pi over 2. You say, how did I get that? 0 plus pi divided by 2. So I want you guys to understand where this comes from. This is the general cotangent curve. We're going to look at this in Desmos, okay? You go, what does that look like? Well, y equals cotangent x. Okay? And remember what we said here. This would be 0 now. This here is going to be pi. Okay? And you say, well, how come I see all these other cycles here? I see infinitely many cycles of that curve for cotangent, right? And that's because cotangent's periodic again. But if I restrict my domain in the same way for that one cycle, we're only going to graph one cycle. We can't graph infinitely many. 0 less than or equal to x less than or equal to pi, I believe, right? Okay. You're looking at what I'm just describing to you, just the cotangent curve. But I want to also remind you there's a little mechanism that I use, which is y equals negative x to the third power. Okay, you go, why did I draw that? Doesn't that curve look similar? It's not the same, but it looks similar. In other words, y is negative x cubed, just like I wrote down y equals x cubed earlier. Okay, we'll change the color. Okay, I'm going to get rid of this. This is kind of what I remember in my mind for graphing sines and cosines. This is y is x cubed. This is y equals minus x cubed. Okay? Here, this is y equals cotangent. And you have those vertical asymptotes. So I just want to put this all together for you guys in your notes, okay? If you guys remember, this general curve, think of y equals that minus x cubed. We're going to go through this. That's what I actually use in my mind here. This is a key. So that was the graph. And let's go back. You know what I'm going to do? I'm going to go back in Desmos and say, hey, Desmos, I want that picture. I want you in my notes. Maybe Elon Musk will buy this one day. He's going to buy my notes, add to existing notes. I'm going to change the title to graphing the others, you know, but it's still, I use the same notability file. There we go. So now we're complete. This is also in your book, by the way. If you said, where is this in the book? I'll share with you guys where it is. Okay? I'm just sharing with you guys those details here in the notes. Vertical asymptotes, x-intercept, the whole thing, ladies and gentlemen. Okay, but generally speaking, you got that A and you got that what? That K. If A is negative, you'll see the effect. But the interval of one cycle is a little different. Where it starts and where it ends is different because this is the cotangent curve. So did anybody look over some of that? Well, maybe you didn't because it didn't write it in Canvas, but if I look at my Canvas notes or just my website, you know, maybe they have something like this. I'm going to say y equals 4 cotangent of (3x). And we're going to want to find, again, the interval of what? One cycle, the period, the vertical asymptotes, all those nice things. Oh my God. Should we close the door? Let's close that door. I'm getting scared. I didn't hear what was going on there. Just close that door. Ooh. Huh? Would that scare you guys? Don't lecture like that? I don't think so. I don't think so. Personally, I don't think so. I'm barely even awake. I don't think this coffee is what waking me up. Maybe I'll lecture like that when I wake up later on. I got to go run and get a whole other coffee. Anyway. A, and what's this? K, you go, oh, that Mr. Judge. What's your period? Pi over K, is that right? So what's that going to be? Pi over 3. So let's write that down. Here's my period. Pi over 3. Maybe I'll just move it. Okay. Now, this is new. This is different. Okay. What's your interval of one cycle? Start at 0, end at the period. I like doing that. Start at 0, end where? Pi over 3. You guys okay with that one? Start at 0, end at pi over 3. Okay, good. Wow. Once you get this, what could you guys say? Vertical asymptotes. X is 0. X is pi over 3. And then you might say, but Mr. Judge, where's that x-intercept going to be at? Do you guys know where your x-intercept's going to be? What do we get through saying? It's going to be midway between 0 plus what? Pi over 3 divided by 2. Is that true? It's midway between those two values found. That's why getting your period is important. Interval of one cycle. Now, what is 0, ladies and gentlemen, plus pi over 3? Do you guys know? Isn't that pi over 3? And then what's pi over 3 divided by 2? It is pi over 6. But you go, but why? Again, more of that arithmetic. Can you find that on my algebra website? Pi over 3 divided by 2. What is that? Pi over 3 times 1/2. And then what? What do you do? And that gives you pi over what? Pi over 6. There you go, ladies and gentlemen. Easy peasy. Lemon squeezy. This is your x what? Intercept. So at this point now, when you sketch, okay, because we're going to sketch this, what information do you start with, ladies and gentlemen? What do you always start with? Yes, good job. You start with your vertical asymptotes right here. Okay? That's how you find it right there. X is 0, x is pi over 3. Those are vertical lines, so you have vertical line x is 0, x is pi over 3. And then what's midway? 5 or 6. Okay, you guys get that there? So far, so good. You get all that important information here. That's why you have it. What happens now with the curve? Why did I draw this information for you guys here? Negative x to the third power. That's again, if you ever graph that in your life, that's what the curve is. Meaning you do what? You go up to the left forever and then down to the right forever. That's the same curve I'm trying to reference here. All right, so you guys can see that there. And there it is, ladies and gentlemen. You've done all the important details that they want you to do. Finding the x-intercepts, finding the vertical asymptotes, and also finding your x-intercept and sketching that curve. There it is. That is it. Easy peasy lemon what? Lemon squeezy, is that right? Very interesting. Okay, you guys good with this one? All right, let's try another one. Y equals, we're going to say this. Did I do that? What did I do? 3x, okay. How about if I just gave you y is cotangent negative x over 3. And then you might say, boy, Mr. Judge, that negative sign is inside again. Well, we're going to have to focus on that part, right? What do we mean by focus on that? What is that? Is that negative what? 1/3 x? Is that true? And what do you guys know about cotangent? Cotangent is also, what's the word? Odd. Thank you. You say, I know it's odd, but what do they mean by being odd? Right? You have cotangent, really negative 1/3 x. It's odd, so that means bring out your what? Bring out the negative sign out in front, because it is an odd function. So I'm using all those ideas that we worked on in the past. You're like, wow. All of those ideas, ladies and gentlemen. So what's this k value now? This is going to be my what? My k. And yes, this is the you can say, is that -1 for a? Yeah, it's a is -1. Is that going to mean something? It will, but it's not going to mean anything for until we sketch the curve. Pi over k, which is pi, what's k? Not 3. K is 1/3. K is always the number multiplied to x. So don't just focus on the denominator. You guys okay with that? All right. And then do your arithmetic. What's a whole number divided by a fraction? I write it that way. Okay, I'm focusing on this arithmetic. Pi, let's get rid of that. This is pi divided by 1/3, which is pi times 3 over 1, which is also known as 3 what? Pi, ladies and gentlemen, 3 pi. So in other words, you just found the period. Your period is what? 3 pi. Yes. Easy peasy, lemon, what? Squeezy. What's your interval of one cycle now? It's going to be 0 to what? To 3 pi. Now, once you have those numbers here, You got a lot of information. Is that right? From here, what could you guys do? You can get your vertical asymptotes, which happens at x equals 0. X equals what? 3 pi. Is that right? And then also, you can get your what? X-intercepts. Or the x-intercept. You say, how do I get that? Well, that's midway between the vertical asymptotes. Okay? Again, midway between your vertical asymptotes. And then, what's 0 plus any number? Itself, that's 3 pi. And then you're dividing by 2. So, ladies and gentlemen, there's your x what? Intercept. So it's based on the definitions and arithmetic. All right. So maybe I want to just get rid of. If you guys see this, it's in your notes or it's in the video. You can hit rewind, right? Anybody go back and watch that stuff? Good for you. That's why it's there. Okay. Instead of trick-or-treating this Halloween, you could watch something scarier. Is that right? All right, so start at 0. Remember this? Start at your vertical asymptotes. X equals 0. And then x equals 3 pi. And then what's midway? 3 pi over 2. Okay, so far so good. But what's going on with this curve? A is -1. What's going on here? Well, if this was the regular cotangent, you would graph it this way. Isn't that what we said right up here? Because this is going to be really that negative x cubed. But what's the opposite of that if we reflect this curve about the what? The x-axis. What happens if we reflect this curve about the x-axis? You know what we're going to see? You're going to see it go this way. It looks like the tangent curve. Okay, it looks like tangent. So when you reflect this about the x-axis, say, where's the x-axis? The x-axis is down here. When that original curve for cotangent gets reflected about the x-axis, you say, why? Because my a value right here is what? It's negative, yes. So if it's negative, then you got the regular x cubed curve. So I wanted to share that version with you guys so you guys can see that. Okay, this is cotangent negative x over 3. So if you said, let me see this in Desmos, okay. Y equals, I think, yeah, they got cotangent negative x divided by 3. Okay. 0, and what was the other one? Was it 3 pi? I think it was 3 pi. Yeah. Okay. You might say, is this that interval of 1 cycle? Well, yeah. Well, how come it has all the other values? We'll restrict the domain. 0. Let's look at x less or equal to what? Was it 3 pi? I think so. So as you guys can see right here, that's exactly what's going on with that curve. Y equals cotangent negative x over 3. Pulls out that negative sign, and then you guys can see all the nice information regarding that example. So you can graph cotangent and what now? Tangent, one cycle. Did you guys know there's even a phone app for Desmos? There's a Desmos phone app. So everything that you're seeing me do here, you can double check your homework yourself. Is that right? You go, there's a phone app. You don't have to be on your computer. You can put it on your phone. I have it on my phone. Is it? Easier? Easier access? There's an app, the Desmos graphing app. So, and then you say, well, is this from your worksheet on the homework? Yes, if I go to my website. On the website, it's going to take you to this graphic, it's going to take you to this